Hi, my name is Asmita Sharma. Today I'll show you how to draw a Lewis structure for CBr4 as well as find out if it's polar, non-polar, its shape, and the intermolecular forces that are related to this molecule. Before we start the Lewis structure for CBr4, we want to find the valence electrons for each of them. So carbon has 4 valence electrons and bromine has 7. So we do 4 plus 4 because there's 4 bromine times 7. So total we have 32 valence electrons in this molecule. First, I will always like to start off by knowing how many lone pairs we have, and we can find this if it's a multiple of 8, that means it will not have any lone pairs. For example, in this molecule it has 32 valence electrons, which 8 times 4 equals to 32. So this means this molecule does not have any lone pairs, so we don't have to worry about that. I also like to know the number of bonds we have before I draw the Lewis structures. To find that, I use the equation number of bonds equals to valence electrons minus the number of dots. 4 minus 0, we have total of 4 bonds. So this gives me an idea on how my Lewis structure should look. So we're gonna start by drawing carbon in the middle because it has the lowest electronegativity. And then we're gonna have 4 bromine, and we know we need to have 4 bonds because we found that through our equation. So we have 4 bromine. So overall we have 32 valence electrons, and when we drew the bromine we used 8 valence electrons. So 32 minus 8, we have 24 valence electrons left. So carbon already has 8 valence electrons here. It has fulfilled its octet rule, so we cannot add any more electrons to carbon. So the only choice we have is to add it on bromine. So let's go ahead and add the electrons on bromine. So we just used up 24 electrons, so that means we have 0 remaining. So this looks good, and always to double check if we have if we drew it right, we count up all the electrons that are drawn and it should equal out to 32, and in this case it does. So this looks right, and this is how you draw the Lewis structure for CBr4. To determine the shape, we cannot use the Lewis structure we just drew here because it's flat, so we need a 3D model. So this is our central atom, and we will add 4 bromine atoms to this. So we end up with 4 bonds and 0 lone pairs. So looking at this shape, we can tell that the molecule geometry is tetrahedral, and since there is no lone pairs, that means the molecular shape and the electron geometry is the same. The bond angle is 109.5, and as you can see, any way you move this, the bond angle will be the same, and it will be a tetrahedral geometry all the way through. So in order to figure out if this molecule is polar or non-polar, we can start off by looking at its electronegativity. Here, if we look at its electronegativity, you can see that carbon has an electronegativity of 2.5, and bromine has an electronegativity of 2.8. So this means that bromine is slightly larger in electronegativity, and carbon is slightly positive, so bromine is slightly negative. So the dipole moment will be pulled towards the bromine. So we would draw a positive sign towards the carbon and then arrow going to bromine since it's more electronegativity. And here, since all of these are going in the opposite direction, we have 4 of them here, they actually cancel out the dipole moment, so we have a symmetry here. So that means overall there is no net dipole since they get canceled out. So that means this molecule itself is non-polar. Since this molecule is non-polar, there can only be one intermolecular force, which is dispersion. That is because all molecules have a dispersion force, regardless if they're polar or non-polar. But this one only has dispersion because in order for molecules to have dipole-dipole or hydrogen bonding, they have to be polar. So we only have dispersion in carbon tetrabromide.